Okay, so in this video, we're going to draw triangles for Desmos. Okay, so let's see. What do we need to do? Well, the first thing is, of course, we need to know where y and where x is. Stretch this out a little more. We need to know the origin, right? Those are important. Then, let's look at each of these corners of the triangle. We need the coordinates for those. Okay, let's do this one first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So this is 10, 1, right? And then this one is what? 1, 2, 3, 4, right? 4, 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. Okay. And then this one is going to be -1, -2, up 1. Okay, great. All right, so let's focus on this line. That's going to be a horizontal line, right? So all these are really lines. There's 3 lines put together, right? And we know that lines are y is equal to mx plus b. Watch my video on lines, and I'll explain to you how to use that equation. But we need a slope and we need a y-intercept. Now, this line that we're going to be doing now, right, this one, is going to be a horizontal line. So that's going to be y is equal to the what? That's right, the y-intercept, which is going to be 1. I do have a video for you on exactly how to draw a horizontal line and also a vertical line if you're interested in that. Okay, and then the formula is controlled by x and how far to draw it. And in this case, it's going to go from here, right, from -2, by the way, -2, and then it's going to be all the way up to 10. So this is the formula you would use for Desmos to draw that line, the base. Okay, then we're going to need another line, right? We're going to need to, let's draw it in a different color. This one. So in that one, I think we're just going to find the slope. There's different ways we can find the slope. Let's see. The slope is the change in y over the change in x, right? Rise over the run. So rise, 1, 2, 3, 4. Okay, and then run, 1, 2, 3, 4, 5, 6. Okay, and we know that this line is going down, right? So it's going to be negative. So the slope is going to be 2/3 when we reduce. Remember, we can also use the formula y2 minus y1 over x2 minus x1, right? This is x, this one's y, this one's x, this one's y. This could be my first point, this is my second point, and then we just pop it into the formula. y2 is 1, take away y1 is 5, divided by x2 is what? 10 minus x1 is 4. That's going to give me a -4/6, which is 2/3 negative, right? Oops, forgot to put negative over here. Okay. So we got the slope. Now we're going to need the y-intercept. Okay, looking at this, the y-intercept is going to hit somewhere there, right? So that's what? 1, 2, 3, 4, 5, 6, 7. Here's 7. Here's 8 and 9. Right? So it's going to hit in this area here. Let's find out if that's the case. So we take y is equal to mx plus b. We take a point, let's say 4, 5, and we got the slope, right? Negative 2/3. All right, let's pop it in. This one's x, this one's y. Y is what? 5 equals the slope, negative 2/3, times what? Times x, which is 4, equal, oops, sorry, not equals, plus b, which I'm looking for. Okay, let's keep working on this. So this is going to be 5 equals what? Negative 8/3 plus b. Okay, I'm going to add 8/3. We're going to add 8/3. So that's 5 plus 8/3 equals b. We're going to change that. We're going to change the 5 into a denominator that has a 3. So we're going to multiply by 3/3, which is 1, which I haven't done anything. So right here is 15/3 plus 8. Let's write that right. 8/3 equals, what's 15 plus 8? 15, 16, 17, 18, 19, 20, 21, 22, 23. 23/3. 3 goes into 23 easily 7 times. 7 times, and then whatever's left over. So that's about right. Okay. So the formula, right? The formula is going to be, let's write it over here. So the formula for this is going to be y is equal to negative 2/3 x, right, plus 23/3. Wow, okay. So that's the formula for that line. Okay, let's try a different color here. Let's go for this line right here. Okay. So what's the slope on this? Well, we'll find out. We'll call this one x, y. We'll call this the second point. This one we'll call point number 1. So y is equal to y1 minus y2, or better yet, let's do it traditional here. y2 minus y1 over x2 minus x1. Okay. Okay, so y2 is going to be what? 1. And y1 is 5, so take away 5. Divided by x2. x2 is what? Negative 2 minus x1. x1 is 4. So that's going to give me what? Negative 4 over negative what? 6, which is going to give me what? 2/3. The slope is 2/3. That's a positive slope. How's that? Well, it turned out that these two lines, this line and this line, right, are perpendicular to each other. They're right angles. So they have opposite slopes. Okay? I mean, if you continue on this way, right, this is a right angle. Okay? And because that's a right angle, it gives us a kind of like it's just a reflection. Okay, so a reflection down here. Move this over, you get a reflection. All right, that's good enough for that. So we know that the slope is 2/3. And where does it hit the y? Where is b? Well, we're going to do the same thing. We're going to go y is equal to mx plus b. We are going to take, we'll take the point 4, 5. We'll take our slope 2/3, and we'll find out what happens. Okay, so we got y is, this one's x, this one's y. Y is 5 equals 2/3, x is 4 plus b, right? Okay, so this is 5 is equal to what? 8 over 3 plus b, right? So I'm going to subtract 8 over 3. Looks very similar to this problem, but that's a positive. This one's a negative 8 over 3. This one's a positive 8 over 3. I'm going to subtract negative 8 over 3. So that's going to be 5. Take away 8 over 3 equals b, right? And we're going to do the same thing here as we did previously. 15 over 3, take away 8 over 3 equals b. 15 take away 8. Let's see. That's 5, 6, 7, 8. That's 7. 7 thirds equals b. 3 goes into 7. How many times? 2 times. So it's going to be a little more than 2 times. And that's right. This is 1, this is 2. So it's a little more than 2, a little more than 2. So the formula, right, for this line right here, I'm going to write it somewhere. Let's see. We'll write it over here. It's going to be y is equal to what? 2 over 3 x plus 7 over 3. We need to set its boundaries, right? So that's going to be bounded by x. It's going to be bounded from what? From negative 2 all the way to here, right? Which is 4. Okay. So that's going to be from negative 2 to 4. All right. And then this one also needs to be bounded. Forgot to do that. X. It's bounded how? Well, let's see. It's bounded by minimum of 4, right? Right here. And then it's going to stop here, which is 10. Now let's use Desmos to see if our calculations are correct. Here's the first one. And here's the line again. And it goes from what? 4 to 10. And it is a line that's going down. So it's a negative slope. Let's look at the next one. This one has a positive slope. Basically opposite to the previous slope. In this case it's 2 over 3. We also see that the y-intercept is 7 over 3, which is more than 2 but less than 3. That's correct. And positive slope going up, bounded from negative 2 through 4. Okay, that's the same. And then the horizontal line, right, that goes from negative 2 to all the way to 10. And there it is. There's our triangle. Okay, let's do the next problem. Okay, here's another triangle. This one's x, this one's y. This is the origin, 0, 0, right? Okay, and then this right here, right, is going to be what? A horizontal line, right? Okay, and then we need to know where it crosses on the y, which is here. Let's see, that's 1, 2, 3, 4, 7, 8, 9. Hits at 9, so that's y is equal to 9, right? And it's controlled by x. How? From where? From this point to this point. This point, right, is here. So that's 1, 2, 3, 4, 5. And then this point here, which is over here, 5, 6, 7, 8, 9, 10, 11. So it goes from 5 to 11. Okay. All right. That looks pretty good. Let's use a different color now. How about this line right here? That's a what? Vertical line, right? So definitely want these 2 points, right? And this particular line, right, is vertical, and it hits the x-axis at 5. So that's going to be x is equal to 5, right? And it's controlled by y in terms of how long the line is going to be, right? It's going to be, it goes from here to here. So that's 1, 2, 3, 4. It goes from 4 to 9. It goes from 4 to 9, right? And again, you can always watch my video on how to draw vertical and horizontal lines. Okay. Now let's focus on this line here. Okay, this point here seems to be 5, 4. This point over here seems to be 11, right? 11, 9. Okay, so the slope, right? The change in y over the change in x, that could be, let's see, that's going to be what? 2, 3, 4, 5, right? And then 1, 2, 3, 4, 5, 6. 5 over 6. Okay. And it's positive, right? So we don't have to worry about the sign there. Okay. And then to find the y-intercept, we use the slope-intercept form of the line. And we find a point. Let's try 5, 4. Okay. This one's x, this one's y. So y is what? 4 equals m, which is 5 over 6. X is what? 5, right? Plus what? B. Now, before I finish that, if I draw a line here, right, it looks like it's going to be a negative number, and it's not very big, right? Over here is what? -3. It's probably between 0 and -3. We'll find out. 4 is equal to what? 25 over 6 plus b. Subtract 25 over 6 on both sides. And b is equal to 4 minus 25 over 6. Okay, remember, the same denominator, 24 over 6 minus 25 over 6 equals b. That's 1 over, wow, that's going to be -1 over 6 equals b. So my skills in drawing a line wasn't that great. So the line is more going like this somehow. Okay, well, I estimated, and it is between 0 and -3. That is true. Okay, it's not perfect, but it's a good estimate. Okay, then our formula here is going to be what? Y is equal to my slope of what? My slope of 5 over 6 x minus 1 over 6. And this is controlled how? By x. Okay, from where to where? It looks like, right, from this point, which is 5, right, to this point, right, x and y, to 11. Okay, and there is my other equation, right? And then this one, and where's the other one? It's up here. All right, now let's see if that works for Desmos. Okay, let's see if it works for Desmos. We got, let's say, x is equal to 5. So it draws a vertical line. Then we're going to put a curly bracket. 4 is less than y less than 9. Curly bracket. And there's our line. Okay. Then I'm going to add another one. Y is equal to 9. Right? It gives me a horizontal line, and that goes from 5 less than x less than 11, and then close the curly brackets. So there's the vertical line. And then I guess we can go with y is equal to what? 5 over 6. Don't forget the x, right? Minus 1 over 6. And there's a line. Oh, that looks good. But it needs to be bounded. How? From 5 to x. From 5 less than x less than 11. Let's close it. And there it is. Not bad. Not bad at all. It works perfectly. Right? Okay. So let's do the next example. Alright, so let's find the corners. This corner, and that corner. Okay. This one's y, this one's x. We know where the origin is. This is 1, this is 2, right? So that's probably 2, 0. Goes over 2, doesn't go anywhere else. This one's 2, and it goes up what? 1, 2, 3, 4. Okay. This one is -1, -2, -3, right? -3, and it goes down what? -1. Okay. So we have our points. Let's do the easy one first. This one right here. That one seems to be a vertical line, right? And it's hitting right at 2. So x is equal to 2, right? And it's bounded by y from what? From 0, right? This is 0. From 0 to here. 1, 2, 3, 4. Okay. All right. Okay, so we got one equation out of our triangle. Let's do this one, right? And again, we can find the slope, change in y over the change in x, right? So that's going to be 1, 2, 3, 4, 5. 5 over 1, 2, 3, 4, 5. Aha! 5 over 5, which is 1. That's going to make our lives easier. And you can see that it's going through the diagonals for each square, right? That's a key for it to being a slope of 1. Okay, do we know the y-intercept? Yes, we do. 1, 2, it's at 2. All right, so the equation for this line is going to be y is equal to 1x plus 2, or y is equal to x plus 2, right? Okay, that's pretty easy, and it's bounded by what? By x, right? That's the independent variable, right? It's going to go from what? -3 till, this was x, this was y, till 2. Okay, so that's how it's controlled. All right, let's do now this line right here. And we got the points, right? Let's find the slope. The slope is going to be what? The change in y or the change in x, right? So we'll do the y. That's going to go down 1. And then it's going to go 1, 2, 3, 4, 5. So 1 over 5. Okay. So let's find the equation of the line by using this formula, right? This is not the only formula that you can use, right? But that seems to be the one that we've been using all this time. So we're going to use a point 2, 0. I think that's the most easiest point that we can use at the moment, right? And the slope is going to be 1 over 5. This one's x and y. y2 over 0. y2 that 2 comma 0, because it's a point that is part of the line, Okay, so y is what? 0. Great. M is what? 1 over 5. X is what? 2 plus b. So that's 0 equals 2 over 5 plus b. And then that means it's 2 over 5 equals b. Okay, so my formula is y is equal to 1/5 x plus 2 over 5. 2 over 5 is between 0 and 1, isn't it? It's negative 2 over 5. See, right? Because you've got to subtract negative 2 over 5. Okay. So it's going to be between 0 and negative 1, which is right here. See? Sometimes it's important to double check these things. And when you're doing a lot of math, of course, you'll mess up a little bit. But sometimes if you have those little double checks, you can see that, it was between 0 and 1. That's not the case, right? It's not here. It's down here, so you have to check your math. Okay, so now let's see if we can do this in Desmos. So the first one is going to be, let's try x equals 2, and it's bounded by 0 less than y less than 4. Okay. Next one is going to be y is equal to x plus 2, bounded by negative 3 less than x less than 2, right? Okay. Okay, it looks very funny right now, but let's continue on. Next line is y is equal to 1 over 5x, right? Minus 2 over 5, right? Bounded by what? We haven't finished that. Okay, so this is bounded by, goes from, let's see, it goes from here, right? Negative 3 till 2. And that's going to be x less than, right? Okay. Negative 3 less than x less than 2. Close it, and there it is. That is pretty amazing, and it does work. So to do these triangles, you're going to need to do a couple of things. First of all, you're going to identify the corners and then making sure you know the coordinates. Make sure that you identify things that are horizontal or vertical lines because those are easier to do. One thing too that I haven't talked about is see how messy my calculations are, and I use a grid system. Do that in your do it on graph paper first. Don't just try to imagine it in Desmos or in your mind. Write it out. That's going to be much easier for you. There's going to be certain situations where, just like over here, you do your math just a little different. You forget a step or negative or something. When you put it in Desmos, you'll see if that comes out right or wrong. But sometimes you can estimate, right? You can do a little estimation, or you can figure out, hey, is it negative or positive, and so forth. And that helps you also in identifying any errors in your calculations. All right, good luck.